So let us start. Okay. So today we are going to talk, we are mainly going to understand what is the relative speed of images with respect to the objects. Okay, means I can write with respect to object or something like that. Okay. तो हम आज की जो टॉपिक है वो मेनली यहाँ पे डाइग्रेस करना चाहते हैं कि अगर मान लो कोई एक ऑब्जेक्ट मैंने यहाँ पे रख दिया, ठीक है, लेट सपोज ओके, यहाँ पे मैंने ऑब्जेक्ट रख दिया, ठीक है, राइट साइड पे मैं क्या कर रहा हूँ, स्क्रीन विजिबल है ना गगन, अनुज, स्क्रीन परफेक्टली विजिबल है, ठीक है।
Yes, sir.
तो देखो मैं यहाँ पे एक ऑब्जेक्ट रख रहा हूँ, ठीक, उस ऑब्जेक्ट की कोऑर्डिनेट क्या दी गई है, x ऑफ ओ एम, ठीक है, y ऑफ ओ एम और z ऑफ ओ एम। x ऑफ ओ एम का मतलब क्या हुआ, डिस्टेंस along x axis, distance along x axis of object with respect to mirror, ठीक है ना। सिमिलरली y ऑफ ओ एम है डिस्टेंस ऑफ ऑब्जेक्ट along y axis with respect to mirror, z of o m means z of distance of image along the z axis with respect to mirror। ओके, तो यहाँ पे अगर ऑब्जेक्ट के तीन कोऑर्डिनेट है, ठीक, उस ऑब्जेक्ट के लिए क्या बनेगा, मेरे पास एक इमेज यहाँ पे क्रिएट होगा, ठीक है, एक वर्चुअल इमेज जो है मेरे पास क्रिएट हुआ, ठीक है ना, आई एम ए जी। अब इस इमेज का भी तीन कोऑर्डिनेट होगा, ठीक है, तो एक्स ऑफ आई ऑफ वेट x of x of image with respect to mirror, y of image with respect to mirror and z of image with respect to mirror। तीन कोऑर्डिनेट इमेज के भी होंगे, ठीक है ना। और इन तीनों कोऑर्डिनेट देखो, ये ऑब्जेक्ट की जो तीन कोऑर्डिनेट है और इमेज के जो तीनों कोऑर्डिनेट है, इनके बीच में एक रिलेशन होगी, वो रिलेशन मैं अभी ड्रॉ करूंगा, ठीक है ना। बट अब मैं एक कॉन्सेप्ट इंट्रोड्यूस करता हूँ, क्या इंट्रोड्यूस करता हूँ कि मान लेते हैं ये प्लेन मिरर तो है और ये मेरे पास ऑब्जेक्ट है, ऑब्जेक्ट का सिमिलर डिस्टेंस पे एक इमेज बन गया। अब मैं बोल रहा हूं कि लेट सपोज इफ दिस ऑब्जेक्ट स्टार्ट्स टू मूव टुवर्ड्स द मिरर, लेट सपोज दिस ऑब्जेक्ट स्टार्ट्स टू मूव टुवर्ड्स द मिरर, then what will happen with the image we want to understand। Okay, we want to directly understand what is going to happen with the image। to understand about what is going to happen with the image हमें क्या बताना होगा, हमें इन सारे कोऑर्डिनेट्स मींस इमेज के कोऑर्डिनेट और ऑब्जेक्ट के कोऑर्डिनेट के बीच में रिलेशन बताना होगा। तो यहाँ पे हेडिंग दे दो, रिलेशन बिटवीन, relation between coordinates of image and object, ठीक है। चलो नोटिस करो, सबसे पहली बात क्या है कि सर जो इमेज जो ऑब्जेक्ट है, मान लेते हैं इस प्लेन मिरर से अगर डिस्टेंस डी पे मेरा अगर एक ऑब्जेक्ट है, तो इमेज भी जो क्रिएट होगा वो सिमिलर डिस्टेंस डी पे ही क्रिएट होगा। दिस इज माय कांसेप्ट, यस और नो, कि अगर मान लेते हैं जो इक्वी डिस्टेंस होते हैं, जो ऑब्जेक्ट होता है मिरर से अगर डिस्टेंस डी पे लाई कर रहा है, तो इमेज भी डिस्टेंस डी पे लाई करेगा। इसका मतलब क्या हुआ कि एक्स ऑफ object with respect to mirror should be equal to x of image with respect to mirror। But then there is another thing, that image is formed in the opposite direction, so I'll have to use minus sign over here। This represent what, that x of distance of object from the mirror is along the right, distance of image from the mirror is along the left। But what is not going to change, what will remain same, ये जो y coordinate है and जो z coordinate है, दोनों का इमेज और ऑब्जेक्ट का, they are going to be similar they, because since y is along the y axis, so देखो ऑब्जेक्ट इमेज का जो तुम्हारे पास डायरेक्शन है along the y axis, it is in upward plane, got it or not, and object का भी similar plane पे, so that is why y of object with respect to mirror is equal to y of image with respect to mirror। Similarly z of object with respect to mirror is equal to z of image with respect to mirror। are you able to understand or not, tell me, ये रिलेशन, ये तीनों क्लियर हुआ कि नहीं क्लियर हो बताओ।
Yes, sir.
Okay, now when these things are clear, now I can differentiate with respect to time। जब मैं differentiate करूंगा with respect to time, what I will get, I'll get a velocity of object with respect to mirror along the x direction, which is equal to minus of velocity of image with respect to mirror along the x direction। Second relation, what I will get, velocity of object with respect to mirror along the y direction still remains same with velocity of image with respect to mirror along the y direction। Similarly, velocity of object with respect to mirror along the z direction still remains same with velocity of image with respect to mirror along the z direction। Are you able to understand or not? These are the three relative velocity relative velocity of image with respect to object relation. Got it or not? What are these? Are the three relative velocity that we want to establish. Let's suppose if object starts to move along this particular direction, it has, let's suppose, velocity v, then the image will also start to move with similar velocity in the opposite direction. Got it or not? Okay, so that is why velocity of object with respect to mirror in x is equal to minus of velocity of image with respect to mirror along the x. Got it or not? Why? Because they are moving in equal and opposite direction. Got it or not? While along the y and z, the velocity remains same. They are neither going to invert, they are neither going to revert. Are you able to understand or not? Tell me. Anuj, Gagan, yes or no? Is it okay or not? Tell me.
Yes, sir.
Perfectly. Okay. Can I move ahead?
Yes, sir.
Yes, sir.
Okay. Now look over here. Now, we know that what we have got as a relation, that velocity of object with respect to mirror along the x direction is equal to minus of velocity of image with respect to mirror along the x direction. Now, these are relative velocity. If two objects are moving in similar direction, let's suppose if we want to write the relative velocity relation, it will be what? Velocity of object minus velocity of mirror along the x, which is equal to minus of velocity of image minus velocity of mirror along the x. Can I write like this or not? This is the relation of relative speed or not? Tell me. Yes or no?
Yes, sir.
Yes or
Yes,
no?
sir.
Tell me, Gagan. Yes. So from this, what I can get? Can I get one relation over here, that velocity of object minus velocity of mirror? Okay, I'm replacing this. This is for x-axis only. Okay, so I will write the direct relation. This is minus of velocity of image plus velocity of mirror. What I get is velocity of object along the x direction is equal to minus of velocity of image along the x direction. So whatever will be the velocity of object, if we even replace this sign convention, or if we replace this mirror term, like if we do not use this mirror term, then also I can get the similar relation. So that means what? Whatever be the speed of mirror, be the speed. Wait. It will not get cancelled. Wait, I think it will not get cancelled because there is a term. Okay. So this is only possible if velocity of mirror is how much is equal to 0. Means अगर let's suppose अगर तुम्हारे पास एक ऑब्जेक्ट है जो एक मिरर के सामने, मान लो ये ऑब्जेक्ट है, ये मिरर के सामने किसी वेलोसिटी से मूव कर रहा है, तो इमेज भी इसको सिमिलर वेलोसिटी के साथ तभी फील होगा जब ये मिरर जो है तुम्हारे पास कैसा रहेगा, रेस्ट पर रहेगा. कैसा रहेगा? रेस्ट पे. लेट सपोज इफ केस 2, what is that case 2? If velocity of mirror is not equal to 0, means this velocity of mirror, means if this mirror is moving towards right or left with some kind of velocity, then what is going to happen? So what will happen is velocity of object, this will go to the right and it will become velocity of image, and that should be equal to twice of velocity of mirror along the x direction. This is the relation. So it depends. Remember that the total relative speed between object and the mirror depends upon two factors: whether the mirror is at rest or whether the mirror is not at rest. The mirror is not at rest, the relation becomes velocity of object plus velocity of image is equal to twice of velocity of mirror. And if the mirror is at rest, then the object velocity and the image velocity are equal and opposite. Got it or not? Are you able to understand me or not? Tell me. Yes or no?
Yes, sir.
Understood? Okay. Anuj, are you able to understand or not?
Yes, sir.
Okay. So remember that from this I can write one biggest point, that velocity of object is equal to velocity of image parallel to the image parallel to the mirror surface. Okay, Now, if I write mirror surface, that means what? We have to consider the normal of the mirror or not. Tell me yes or no. So along the normal of the mirror, what happens? The velocity of object and the velocity of mirror images are remaining similar and equal and opposite to each other. But let us consider another case. So you are aware of this horizontal case, but I'm considering that whether this particular object is moving. Let's suppose if I have a mirror like this way, okay, and I have an object. This is my object. It starts to move with velocity v like this way, got it or not? So what is going to happen for the image? You need to predict. Now remember that whenever the object moves in the vertical direction, means it is okay, it is parallel to the surface, then what will happen? The image over here, whatever the image that will be formed over here, it will be also moving with similar velocity along the perpendicular to the normal of glass surface. Got it or not? Along the perpendicular of the normal of glass surface, remember that velocity of image is equal to velocity of object, and that is similar. Understood or not? Tell me yes or no. If I have an object which is moving perpendicular to the normal of glass surface, then the image will also move with similar velocity, and the velocity of both of them should be equal to each other. Are you able to understand? Gagan, yes or no? Anush?
Yes,
Yes,
sir.
sir.
Yes or no? Okay. Now, see, first we considered horizontal, second we considered vertical, third there is an inclination. Okay. So last an important case. Remember that this is the most important case. From this, many questions have been asked. This is my mirror. Okay. Now I have an object over here which starts to move with some kind of velocity v. Okay. With some kind of velocity v along this direction, right or not? Then what will be the velocity, what will be the relation, or what will be the diagram for the image velocity? Can you draw it? Draw it first. Try to draw it. Tell me. So what will happen? Try to understand. See, when
इमेज
the
नीचे जाएगा.
देखो, सबसे पहली बात, when the object is over here, try to understand this object has two component of velocities or not. Tell me. First, it has this component of velocity. Okay, means x component which is making angle some kind of, let's suppose this velocity is making some kind of, I will draw it backwards. Okay, making it straight. Okay, right or not? So look over here, this velocity is making some kind of angle theta with the mirror or not? Tell me yes or no. So that means what? This velocity will have again two components, one component along the horizontal, wait, one component along the horizontal and one component along the vertical. Yes or no? This particular object will have two velocities component. If this angle is theta, so can I say that this angle will be also theta? Yes or no? Gagan, yes or no? This angle will be also theta, na? Or which angle will
Yes,
be?
sir.
Yes. Uh, is I'm sure, na? Yeah, this angle will be also theta.
Yes, sir. Corresponding angles.
Yeah. So this will be what? V cos theta, and this will be what? V sine theta. Yes or no? Now we know that what happens if the velocity is in the vertical direction, nothing is going to change for it. But if the velocity is in a horizontal direction, what will happen? It will invert. Okay, but the magnitude remains same. So that means what? For the object, there will be an image over here. Okay, this will be my image, and this will be also making similar angle theta over here. Okay, wait. This will be also making similar angle theta. Yes or no? What will happen with this? That this will also make similar angle theta over here. Okay, now if it is making theta, so that means what? For this image also, what will happen? A velocity will be there. Okay, of course, one velocity. But for this velocity again, what will happen? There will be two components, one along the x-axis, one along the y-axis. So look over here, this will be your v, this will be theta, v cos theta, and this will be along v sin theta. So if someone asks you what is the relative speed along the y-axis between the image and the object, it is equal to 0, but relative speed along the x-axis between image and object is how much? It is equal to v sine theta minus v sine theta, and which is equal to 2v sine theta. Are you able to understand or not? Tell me yes or no. Are you able to understand, everyone? Anuj, Gagan, yes or no?
Yes.
Yes or no? Gagan, Anuj, any kind of doubt here?
No, sir.
No, no, Anuj, no doubt now. So what will happen when you place the object, when it is moving like this way, what will happen? It will have an component of velocity along this direction. And for that case, image will also have an velocity. What happens? I told now that whatever be the velocity along the x-axis, it will invert for the image. Whatever be the velocity along the y-axis, it will not change. Means if you place the velocity along the normal of the mirror, it will invert. If you place the velocity perpendicular to the normal of a mirror, what will happen? It is not going to change. Understood or not? So remember this line. Velocity perpendicular to the normal are going to be in similar direction. To be in similar direction, having similar magnitude. Velocity parallel to the normal are going to be inverted, or in opposite, are going to be in opposite directions with similar magnitude. Got it or not? Tell me yes or no. Understood or not? Gagan, Anush, understood?
Yes, sir.
Completed? Got it or not?
Yes,
Okay.
sir.
Yes, sir.
So all of these three things. First, what I represented. First, you need the coordinate transformation. Second, relative velocity. Third, relative velocity relation. The mirror is also moving. Fourth case, in vertical direction, it is similar. Fifth case, I have included both horizontal and vertical. Next, I deduced 2 points of it. Okay. Now, let us move to one numerical on this. So level 1. Okay. Now, let us consider, let's suppose I have an object which is moving with how much velocity? Okay, let me just take this. Okay, it is moving with velocity of 10 meter per second. Okay, write this question. I have an object which is moving with velocity of 10 meter per second for an mirror which is fixed like this way. Okay, the mirror is fixed like this way. From tomorrow, I'll mix much more questions. Okay, I have got tomorrow. I'll start with Ahmad Kamal and I read out. Okay, so be prepared for tomorrow. So this is my mirror. Okay, which is fixed to some kind of ground. Okay, now the angle between the mirror and the ground is how much? 60 degree. What is the angle between mirror and the ground? It is equal to 60 degree. So what you have to calculate? You have to calculate the image velocity. Remember that you have to calculate image. Which kind of velocity? Resultant velocity you have to calculate. Find the image resultant velocity. Calculate Mari first. Gagan, ಸ್ವಲ್ಪ ಕನ್ನಡ
Sir.
ಬರುತ್ತಾ?
Sir.
ಸ್ವಲ್ಪ ಕನ್ನಡ ಬರುತ್ತಾ?
Yes, sir.
Yes, I'm learning Kannada fast.
Yes, sir.
Yeah. Do this question. One minute. I'll
So 10 root 2.
10 root 2. No. Think again. Hello. Yes, ma'am. I'm in the room, ma'am. Tell me. 10:30. Correct. Any problem? Oh, okay, okay. I'll bring. Type C cable also, na? Okay, okay, okay. I'll bring. I'll bring. Just I'm drinking little bit coffee and I'll come. Okay. Yeah. Okay. Solve this question. No, try to solve this. This question is not hard. You have to think little bit. I told you again now. Little. If I am giving you level 1, do not think that it is very easy kind of question. You have to think little bit, Gagan. Think, buddy. Hmm. This question is at best. I'm telling you. And this is J Advanced 2011 question. Again, J Advanced question.
That's why I'm not able to solve.
That's why you are not able to solve, huh? I'll kill you if you are not able to solve. Okay, can I solve it? Should I solve it? Tell me.
Sir, 1 minute.
Yes, sir.
Sir, options are there, sir.
Options. uh, okay, so okay, I'll no, no, it will become difficult. Like, wait.
I am getting answer like 10 under root 2 plus root 3.
Option A, 2 meter per second. Option B, 3 meter per second. Option C, 4 meter per second. Option D, 6 meter per second.
Sir, none of the options match, sir.
Now you got to know now why this J advanced stuff. This is the reason. Okay, okay, I'm removing this part. Wait. Okay, so let us bring it over here. It's of no use for me. Okay, so now look over here. See, this mirror is making how much angle? 60 degree. Okay, means this mirror was making. Wait. Set. Okay, this mirror was making some kind of angle 60 degree with the horizontal. Okay, now when it is making some kind of 60 degree with the horizontal, that means what? Let's suppose if I have an for this object, what will happen for this object at the similar distance? Which kind of distance? Along the normal. So first you whatever will be the object image given over here, whatever you get, first you draw two things. Let's suppose, wait 1 minute. Okay, so this is my okay. So let's suppose I consider that my object is over, image is formed over here. Now you know that first I will draw one normal for the object. Along that normal, in the backward direction, what will be created? Image will be created or not? Remember that image will neither be created anywhere. Image is never going to be created anywhere. Image will be only created at the point on the normal. Okay. So let's suppose for this mirror, this is the normal. Yes or no? This is the normal. And on this normal axis, object is kept over here. Just directly opposite on this normal only. If let's suppose this distance is D, at the similar distance, what will happen? The image will be created. First important point. First important point you should remember. Look over here. Along the normal, what I have told, along the normal, like if you calculate, if your velocity parallel to the normal are going to be in opposite direction, that why it is happening in the opposite direction? Because of the relative picture. Okay, so if you consider this as plane mirror along this normal, let's suppose the distance of object is D. So what will happen on the similar normal? What will happen? The image will be created in the opposite direction with distance D. Okay, so here also what will happen? The image will be created at distance D. Got it or not? First important conclusion, yes or no? Understood, Gagan? Next thing,
Yes, sir.
okay, now try to understand. Like let's suppose this angle is total how much? 60 degree over here. Okay, this angle was 60 degree. So let's suppose if the object is moving towards this side, if your object is coming over here, what will happen? This also angle will be 60 degree or not? Tell me yes or no. This object velocity will be inclined at 60 degree with the mirror or not? Tell me. Let's suppose object was moving like this way. Mirror was this way. Object was hitting at 90 degree. Got it? Mirror starts to rotate little bit. When it starts to rotate, you know angle, incidence angle shift by similar angle. Yes or no? So let's suppose if the mirror has been rotated by 60 degree, incidence angle will also be shifted by 60 degree. But the reflected ray, this reflected ray from here, this will be shifted by how much degrees? 120 degrees. Got it or not? So that means what? That if it is 120, this angle will be also how much? 60 degree for the reflected ray. Join it over here with the mirror, with the image. This reflected ray will form the image in the backward direction over here. Understood or not? So this means what? That the angle over here, try to understand that the angle over here made by the image with respect to mirror is how much? It is going to be always 60 degree. Gagan, understood or not? Anuj, understood or
Yes,
not?
sir.
Tell me. Should I repeat one time? Are you able to understand now? Anuj?
Yes, sir.
Okay. So it's not hard. You have to imagine a little bit. What if I rotate by 60 degree, incidence angle rotated by 60 degree, but the total shift in the angle will be with the reflected ray will be 120 degree. So this grazing angle with the surface becomes 60 degree. If it is 60 degree, what will happen? You know that back tracing of the reflected ray forms the image. I trace the back tracing, then that means what? If this is 60 degree, this angle should be also 60 degree. Now, based upon this, I can do two things. What I can do? I can write the component form of the velocity. Yes or no? First, it will have two components. One perpendicular. That is going to be how much? That is going to be, let's suppose if this is angle 60. If this angle is 60, okay, this angle is 90. So this angle will be how much? 30 degree now, Gagan? Yes or no?
30.
This will be 30 now. Yeah. This will be how much? 30. So this is how much? V sine 30 degree. Similarly, for this image, what will happen? There will be a horizontal component that will be what? V cos 30. Wait. Is I'm doing correct? Along the direction. Okay. Perpendicular. Okay. Wait. 1 minute. I should draw on that only. Okay. Wait. So now look over here. This velocity has first one component along the normal. This is what? Let's suppose this angle is 60. This is 90 degree. This will be 30 degree. So V cos 30 along the normal, and it has a perpendicular along the surface, parallel to the surface, and that is what? V sine 30. Understood or not? This is velocity of object, velocity of object. Similarly, this image will have two components, one along the normal, that will be what? V naught, V of I, cos of, similarly, this is 30 degree, so it will be cos of 30 degree, and it will have one component along this side, and this will be what? V of sine, V of image of sine 30 degree. Understood or not? Gagan, are you able to understand or not? Tell me. Perfectly now? Is this correct or not? Anush Gagan, are you able to understand?
Yes.
Yes, sir.
Okay. Now look over here. If I know all of these things, we know that, like, try to understand that the V naught of cos 30 should be equal to minus of V of I cos 30 degree. Yes or no? So let's suppose if V naught is 10, velocity of object is 10. So velocity of image will be how much? It will be again minus of 10. Understood or not? So velocity of object is 10, so velocity of image will be minus of 10. Okay. Now, let's suppose if I write in minus 10 in magnitude form, it will be only 10 over here. Understood or not? So look over here. Next thing, if I know the velocity of image, which is 10, okay, mm, it is correct. What it is asking? It is asking find the image resultant velocity. Okay. So if it is asking the resultant velocity, this is my resultant velocity over here. Okay. So this resultant velocity will be how much? It will be root over velocity of image square. Again, it is going to be cos 30 and Wait. Why it is happening like this? It should come as 4 cos 60 v of I square cos square 30 degree plus v of I square sin square 30 degree. Yes or no, Gagan? So this will become what? Velocity of image is equal to, this is how much? V of velocity is 100 into cos square 30, that is by 4, plus sin square 30, velocity of image, that is 10, means 100, sin square 30, sin 30 is how much? Wait, 1 minute. What is cos 30? Root 3 by 2, yes or no? So it will become uh, 4 into 3 plus 100, sin square 30 is 1 by 2, so it will become 1 by 4. Okay, so this velocity of image becomes how much? Root over, this is total 200, wait, like this is 300 plus, it is 400 divided by 4, which is equal to 10 meter per second. Okay, so again velocity of image is going to be 10 meter per second only, resultant velocity, but the velocity equation, like velocity resultant velocity vector, what it will be 10 into cos 30. Cos 30 is how much, Gagan? Root 3 by 2. So 10 root 3 by 2, it will be along this axis. So I'm considering this axis to be what? Like if I'm considering along 10 root 3, let's suppose this is my x axis, so along minus of I cap plus it will be 10 by 2 along j cap. Okay, but this is not correct. If I see, if I write like this, it is not perfectly correct. Got it or not? Because look over here, this resultant, what we have done is, like we have written the object velocity to be 10 meter per second, and we are trying to write the resultant velocity of image. Okay, so resultant velocity of image, I will get the same. Now when we are getting it same, but if you want to write in vector form, I will have to consider this normal to be x-axis and this perpendicular to be y-axis. Okay, but if I am considering this, again, it will bring some doubt over here. Why it will bring some doubt? Because we know that what will happen, like this mirror has been rotated by 60 degree. So what will happen? The axis will be also rotated by some kind of 60 degree. I have done this now, Gagan. Hello. Let's suppose this is my
Yes, sir.
x-axis, this is my y-axis. So let's suppose if y-axis is rotated by 30 degree, what will happen? X-axis will also have to be rotated by 30 degree. And then this new y-axis, new y and x-axis coordinate becomes what? New y-axis, if I want to write, it will be what? Y sine 30, and x-axis will be what? X prime will be x prime, sorry, y cos 30, and this x will be equal to what? If I write x prime, it will be x cos of 30. Got it or not? So these are the property. If you rotate by 30 degree, this also rotates by 30 degree. So what will happen? Since it is going to rotate by similar angles, so we are ignoring that fact, and therefore I am writing velocity v vector as 10 by root 3 by 2 minus of I cap plus 10 by 2 j cap. Are you able to understand or not? Tell me. Resultant velocity calculation, are you able to understand or not? Tell me. Yes? Anuj, Gagan? Yes or no? Hello?
Yes.
Gagan, see, what was there?
Sir, once more, sir.
I was having the velocity. Object was moving with some kind of 10 meter per second. Okay. Now, if the mirror is inclined at 60 degree, what will happen? The object will be also inclined. Object will also incident at 60 degree, but the reflected light will make 120 degree over here. If it is making 120 degree, so this reflected light will make 60 degree with the
Sir,
this mirror.
but the object is incidentating at an angle of 30 degree, right?
Yeah. So if it
Angle of
is,
incidence is.
yeah, so it is correct now. If this is 30, this is 30. So this will become 60 or not? So 30, 30, 60 plus 60, it is
Ah, yes,
120.
sir, yes, sir.
Yes or no? So now if this is 60 degree, that means what? We know that for the reflected, right? If we back trace it, what will happen? Image will be formed at that point. So I have traced this reflected, right? And I know if this is 60 degree, this angle will be also 60 degree. This means what? That along the normal, image is making how much degree with the normal? It is also making 30 degree with the normal. So it will have two component, one along the normal, one perpendicular to the normal. Similarly, object will have two component, one along the normal, one perpendicular to the normal. Okay, so when I write along the normal, we know that the velocity along the normals are equal and opposite. So velocity of image become minus of 10 meter per second. If I want to calculate the resultant velocity, it will be v of I square cos square 30 degree plus v of I square sin square 30 degree. When you find it to be velocity equal to 10 meter per second. Are you able to understand it or not? Tell me now. Got it or not, Gagan? Yes or no? Hello? Gagan, able to understand?
Sir,
Anuj?
sir,
Okay. Tell
sir,
me.
I have sent in WhatsApp, sir. Why can't be the velocity by like that, sir? I have sent it out, sir. You see one, sir, in the group.
I'll check it. Yeah, I'm checking it. Gagan, first important thing, this mirror is not plane. Okay, means this mirror is not making 90 degree. What you have told, see, if this is my mirror, if this is my object, this is along the normal, this is along the image will be formed along the normal. So if this is velocity of image, velocity of object, this will be velocity of image. But if I rotate this mirror by, let's suppose, 30 degree, what will happen? Both of the object and this image will be also rotated by 30 degree. This one will be also rotated by 30 degree. So if I make the mirror along this side, what will happen? Along the normal also, the object will have similar velocity still. This is velocity of object. This is velocity of image. Okay. Now what you are doing is you are saying that, sir, previously, let's suppose if they were inclined, if it is hitting at 10 meter per second. Okay. So you have rotated it by vi sin 60. Then why you have rotated by vi sin 60? Why you are considering 60 degree? It should be 30 degree now.
Sir, no, sir. Like first, this incident ray will fall with the on the plane at the angle of 30 degree, right, sir?
Yeah,
So reflected angle of reflection will also be 30 degree.
but you have
Sir, now if we backdraw that reflected ray, there will be a point where image will be formed. On that line only, image will be formed, right, sir?
yeah.
On the reflected line.
Huh.
So image should have a velocity along the reflected ray.
Yeah.
So if we resolve that reflected ray into two components, sir, one along the object coming like 10 meter per second horizontal, and one another vertical.
Okay. Now what is the mistake you have done over here? That when this is my object, okay, this is hitting at some kind of 30 degree with the incidence. Okay, image will also go at 30 degree only. Okay, but when you are calling it to be vi sin 60 degree, why you need to call it? You try to do like, if you consider over here, if you consider for the reflected case, we'll have to resolve.
Sir,
Uh-huh.
sir, that's only, sir. I am reflecting this reflected ray in like vertical, one vertical direction and one horizontal. Horizontal means I am telling like 10 meter per second, the object coming direction, right, sir? I am resolving into that direction. When we are resolving 30 plus 30, 60 degrees coming, right, sir?
Huh.
So,
Wait. See, this is my velocity along the reflected ray or not? Tell me. This is my velocity of image along the reflected ray. Yes. Okay. Now, if this is my
yes, sir.
velocity, it will be resolved along two components. Now, one, this is vi cos 30. Yes or no? And this is vi sin 30. Yes. Simple. Similarly, for
Sir, why can't we resolve into the 10 meter per second, sir? Into that angle of 10 meter per second.
yeah. So why, Gagan, this image, how to resolve any vector? You need to learn. See how to resolve any vector. First important condition: if I have one vector, let's suppose if this is let's suppose this is my vector quantity. If I want to resolve it, I'll have to first draw a perpendicular. If I want to draw, if I draw on the perpendicular, then you have to make what is the angle with the vertical or either with the horizontal. You can't compare the angles with respect to another thing, got it or not? You have to consider always the angle of the vector with respect to horizontal or vertical. Here, when you are considering either you can take 60-degree, either you can take 30-degree, but you can't take the particular this angles over here, this 30 and 60. You will have to always consider this 30 and this 60, got it or not? You will have to take these angles.
Sir, why, sir? Sir, because I'm not doing anything wrong, sir. Reflected ray along the 10 meter per second will be VI cos 60 degree, and another one vertical will come, sir. It will be VI cos sin 60 degree. That's it, right, sir? Nothing wrong is going on there, right, sir?
If I let's suppose if you told me, sir, if I resolve along this path, okay, if I resolve along this path, so this angle is total, let's suppose theta plus some kind of gamma over here, okay, theta plus gamma. But then you will have to draw a perpendicular with a similar angle over here, theta plus gamma only, and this will be your perpendicular. Understood or not? You can't consider that. Let's suppose if you draw one theta plus gamma over here and you will make one another theta over here. No, that is perfectly incorrect or not? Tell me.
Sir,
Huh.
sir, I didn't understand, sir. Sir, how, sir?
Listen. This is, let's suppose, if this is my vector, which is, remember that always, see, do not get confused. See, if my vector is there, which is making some kind of angle theta, so this angle, this particular angle should be how much? 90 minus theta, definitely. This is the rule. If I make, see,
Yes, sir.
resolution only happens for a vector quantity. What is that particular concept? Like, let's suppose if I in a Cartesian coordinate plane, if I have any kind of vector, it is making some kind of angle theta, it will have two components. It depends upon this perpendicular length and this base length. Okay, so if you make theta plus gamma, what will happen? This perpendicular and base will change or not? Tell me. So again, you will have to bring it, and this, try to understand, this perpendicular is coming by this component over here. So let's suppose this is my vector length hypotenuse. Okay, so here perpendicular will be h sine theta, and this is my h cos theta. So when you are drawing this hypotenuse, where here, if you are considering, let's suppose this is my, sir, image, I'm taking along the particular 10 meter per second direction. So this is 60 degree, but you try to understand, if this will be 60, this angle, this here, 90 minus 60 will be how much? 30 degree now, but that is not possible now. This angle is 60 degree over here, it is not 30. So try to understand, see what you are saying.
One second, sir.
I'm making it. I know what you are getting, why you are getting confused. Okay. So look over here. This is my image, velocity of image. This was my normal. This was my reflected ray. So this is 30. This is 30. Okay. This was, sorry. Yeah. Wait. Previous on the 30 only. Okay. So this is, let me erase this. So line is moving along this side. This is my velocity of image. This is my velocity of object. Now you are saying, sir, I can take now velocity on this side, the velocity of image cos 60, okay, is equal to velocity of object. But Gagan, if you consider that, if you will consider that, what should be the property? How come I can take the resolution of two vectors? Remember that if I have two vectors, let's suppose this is my vector 1, this is my another vector, second vector v1, vector v2, then you can't do, if you want to calculate the net resultant, you will not be able to do that. I can consider the both angle at the same time. This is the theorem. Why it is the theorem? Because what is going to happen, this vector has different length and this vector is going to make different length. Try to understand, this v2 will have another perpendicular p1 and it has base p1. Here v1 will have another perpendicular p2 and base v2. Now base b1 is in opposite direction, base b2 is in another opposite direction. Perpendicular p1, although they are similar, but still when you are going to write the resultant, you will write p1 plus p2, not p1 is equal to p2. Okay, like let's suppose if I resolve this, what it will be? Along this side it will be v1 cos theta 1. Along this side it will be v1, sorry, sine theta 1. This is velocity v1 cos theta 1. In this side it is v2 cos theta 2, and this side it will be v2 sine theta 2. So when you resolve it, when if I ask you what is the net force along vertical direction, net force or net velocity along vertical, what it will be? v1 sine theta 1 plus v2 sine theta 2. So try to understand, you are actually adding those terms. You are writing p1 plus p2. You are not writing p1 is equal to p2. So are you able to understand? If you are taking the resolution, if you are resolving the vector, remember that their length will be added. There will be resultant length, not the equal length. Understood or not? Tell me. Are you able to get me or not? Correct?